Hello, hello, am I audible? Hello,
Yes, ma'am,
Yes,
you are
ma'am.
audible.
Yes, ma'am.
okay, so let's start our uh, last discussion where we left, and I got the feedback that atmospheric structure is not explained well, and so you want me to explain it again.
Ma'am,
Hello,
ma'am,
yes, yes.
ma'am, the slides of the lecture aren't uploaded to Moodle or Teams. Can you please upload those slides so that we can refer to those after the lecture?
Already, I have uploaded the slide on Teams. So once this lecture is finished, I will upload the slide of this lecture. Okay. So I'm uploading the slides only after I finish the whole content PPT. Because see, if I get any comment and I have to um, make modification, so I do not want to put the slide before the modification. So attend the class, and after the whole topic is over, I will upload this slide. I have already uploaded the slide of last lectures. Okay. Okay, so atmospheric layer. The question was how the temperature is changing in the atmospheric layer, and what is the reason of increasing or decreasing the temperature in different layers. So let's start from the lowest layer, which is the troposphere. Troposphere, the temperature is decreasing because of the distance from the sun, or you can say uh, s- the earth's surface, which is heated by sun. um, as this distance increases, the temperature decreases. So actually in troposphere, basically the temperature change is governed by heating of the earth surface. So once the earth surface is heated, that means what will happen? It will re-emit the long wave radiation, right? So short wave radiation will be absorbed by the earth, and long wave radiation will be emitted after absorbing the energy. So that is the main reason for temperature change in the troposphere. So once the distance from the earth is increasing, the temperature is decreasing. However, there is a isothermic region in stratosphere. That means the temperature is almost constant, which we can see here also, anywhere from about 20 kilometer or so. And the reason for that is because above that isothermic layer is ozone layer which exists. So ozone uh, absorbs most of the ultraviolet radiation, and therefore maintains the temperature below that layer, and also the same is responsible for maintaining the temperature in like upper part of the stratosphere. And that is why the stratosphere in the stratosphere the temperature increases with height. So is that clear now? Right. So in troposphere, long wave radiation emitted by earth is responsible for temperature change, and that is why it is decreasing with height. In the stratosphere, ozone, which absorbs the UV radiation, is responsible for change in temperature. That is why the temperature increases with height, because it is maintaining the temperature within the stratosphere, because of the UV radiation absorption. In mesosphere, uh, the explanation given by the scientist is, however, there are like few explanation is given by for mesosphere. The mesosphere is some in some of the text it says like it's very you can say, miraculous layer, because very little is known about this layer. But whatever is known, according to that, mesosphere has a very low amount of the gas molecules. That is why there is uh, not much absorption of solar energy in this layer, and which resulted in decrease in temperature in mesosphere with height. And whatever energy is there, that is because of the you can say, the whatever stratospheric energy is actually contributing to the mesosphere. So basically we can say the mesosphere, because of very low amount of the gaseous molecule, does not absorb much energy as compared to, like, the stratosphere or the thermosphere above that. And this is the reason for decreasing temperature in mesosphere with height, and the coldest point is the mesosphere is mesopause, and that is minus 90 degree, around minus 90 degree centigrade. The layer above mesosphere, which is thermosphere, again, because of the presence of oxygen and nitrogen in this layer, there is a large amount of UV and X-ray energy absorption in particular layer, this thermosphere, and therefore it results in increase in temperature with height. Even a part of thermosphere, which is known as ionosphere, um, is because of the energy absorption, the gas molecule get charged, and they actually release the electron and become ions. So that layer extends from 150 to 200 kilometer from the Earth's surface, while the whole thermosphere can extend from 90 kilometer, around 90 or 85, 90 kilometer to 500 kilometer. But during very active sunny days, means when sun is very active, this may extend to 1000 kilometer even. And as I told you, the composition of mesosphere is not known, and therefore its structure, the temperature structure is also very, means, this is what reported, but like very little known about the mesosphere. So scientists launch all the space shuttle in thermosphere. So whatever space shuttle we see, they are not see, actually we know, the satellite which are working is in thermosphere. And as I told you, okay, mute your mics, okay, mute your mics, please mute your mics. So as I said, in thermosphere during very active sunny days, the thermopause can extend up to 1000 kilometer, because it expands and the air density reduces. It's like very light air during that hot days. So what happens, it puts or it applies the drag on a space shuttle in order to launch the space shuttle successfully, as well as to make it to move in a defined orbit. The scientists take this particular drag force into account while designing the space shuttle. Okay, so that is what. One minute. What is going on? Why there are two meetings? Okay, all of you mute your mics. Shivam, mute your mic. Please mute your mic. Okay, all of you are here, 175 student, right? I can see two meetings. I don't know if someone else has started the meeting. Okay, wait, maybe. Okay, so now is that clear? The atmospheric layer composition and their role in temperature gradient is clear or not? Just tell me if it is still not clear to anybody. Anyone can tell. Okay, can you tell me if it's clear? Astha Jain, Abhay Agrawal, Abhinav Kumar Singh, Abhinav Thapa.
Ma'am, it's clear.
Yes, ma'am, it's clear.
Okay, thank you. Now we will move to the meteorology. So I have included the information in this slide, whatever I have explained already. You can go through these information. So I have already taught this mixed layer, planetary boundary layer. There are some within the mixed layer. There are surface layer and other layers are there. Residual layers. Residual layer exists during the night time. You can go through this. There are like much material available on this topic mixed layer. And because of the change in temperature during day and night, this mixed layer is further divided into surface layer and the residual layer. Surface layer is actually the layer which is very close to the surface and which seems like maybe zero turbulent or no turbulence. This is what the assumption is. So there are some more information on mixed layer. I think I am not teaching you in this class, but you can see it on website and in other books also. So just go through the mixed the surface layer and residual layer. What are they? And make the note for yourself. Okay.
Ma'am,
Yes.
ma'am, how high does the surface layer extend over the Earth's surface?
No, no, extend. What do you mean by extend? There is a
As
the
in like 1 kilometer, two
layer.
kilometer, like that.
No, no, no. Within mixed layer, the lowest one layer, which will, because of the friction between the gas and the earth surface, it will, this particular layer is very thin compared to whole mixed layer, and it has relatively, you can say, very different property than overall mixed layer. So go through the text given on website, even the books. I'm not covering it. I covered in one of the class, but a student found like it's too much to learn about that. If you are interested, you can go through that. So
Okay, ma'am.
I'm not teaching it. Okay.
And ma'am, can you please upload these slides?
I will upload after I will finish the whole topic. Okay, because if I want to make changes, then I do not want to have the multiple PPT loaded on MS Team. I want to upload the final version. Okay, so once
Okay.
I will finish the topic. I will upload it like I uploaded the last 2 or 3 lectures. Now, now we need to know how this meteorology, the meteorology near the Earth's surface governs the uh, dilution and dispersion of the pollutant which are emitted from the different sources. Okay, so this is very simple diagram. What it explaining is, say there is an air parcel emitted from any source, for example from vehicular tailpipe. How will that parcel move up or down, um, and will be then diluted and dispersed in the atmosphere. So let me connect the board. uh, I have the cord here. Okay, I don't have the cord. Okay, can we just discuss it in this way? Say if the air parcel what coming out from a tailpipe, vehicular tailpipe, its temperature will definitely be greater than the atmospheric temperature or environmental temperature around the parcel, right? So if that parcel will move up, if there is a lapse, I think I have not taught you lapse rate, right? Temperature lapse rate. Okay, I think let it. Okay, this parcel will move up if it's a light, warm air parcel, and the temperature around this parcel will means it will try to mix with the surrounding air, and it will cool down until the temperature becomes same, like whatever is the temperature of air parcel and surrounding air, then it will not further go up, right? So if this air parcel is cooler than the atmosphere, then it will not go up, right? Because the cooler air parcel will be heavier in weight. It will try to subside. Subside means it lifts up, then it will go down because the temperature inside the air parcel is lower than the surrounding temperature, and the air parcel is heavier. Therefore, air parcel is heavier than the surrounding temperature. So we can see in the first left hand side figure what it says. This I have taken from one of the website. I will just put the source of this you can say picture. So air inside and outside air, if this is same, like whatever the temperature of inside the air parcel and the outside the air parcel is same, in that case there is no mixing. It will not neither go up nor go down. So it will remain in the atmosphere as it is. Now the second, can I have a pointer? Okay. So in the second picture, when the temperature inside the air parcel is different from the surrounding air, then especially if it is warmer than the surrounding air, then what will happen? It will go up and it will lift until there is a there will be no temperature difference between air parcel and the surrounding air. So this is what happens, and that is why we like a warmer air parcel goes up and we see the cloud formation in the atmosphere. So here on the right hand side, if the air inside is colder than the outside air, that means what will happen? The density of the air inside the parcel will be greater than outer air. Then the parcel will sink, it will come down, right? Because it is heavy. So this is simple phenomena. I think you must have learned this before also, but I just wanted to go through it quickly. Now, as I told you in just previous slide, that the warmer air parcel goes up, and that is the reason for the cloud formation. So this is what is showing here. The dry adiabatic lapse rate means, we will learn what is dry adiabatic lapse rate and wet adiabatic, which is 10 degrees centigrade per kilometer in the atmosphere, means the temperature decreases with 10 degrees centigrade in 1 kilometer, uh, like uh, like through a different altitude. This caused the actually the condensation inside the air parcel, and that condensation of water vapor inside the air parcel allows formation of the cloud. Once the water vapor inside the air parcel condenses, that means what will happen? If the air parcel is moist, then the temperature lapse rate, or the air parcel will become heavier, right? So that is how the cloud form in the atmosphere. Okay, so this is what. So atmospheric stability means whether the air parcel will remain on the earth surface neutral, or it will go up, or it will sink towards the earth surface. That phenomena are known as atmospheric stability. So first case, when the air parcel will not move up or down, that is known as neutral case. Stable case, when even air parcel will try to move up, but because of the temperature, the density inside the air parcel is higher than the outside density, it will subside. That is, it will go down or sink in the atmosphere. That is known as stable atmosphere. And unstable, when the air parcel which is coming out from any source is warmer than the surrounding air, and because of the lighter weight it will go up. That is the unstable atmosphere. That actually depicts, or you can say indicates the unstable atmosphere. So this is written here already. So the temperature lapse rate in the atmosphere when there is no moisture is about 10 degrees centigrade per kilometer, but when there is a moisture in the atmosphere, then this lapse rate will reduce to 6.5 degrees centigrade per kilometer. Okay, what is the reason for that? Why the wet adiabatic lapse rate is lower than dry adiabatic lapse rate? Okay, try to find it out. It is something related to latent heat of the water. Okay,
Ma'am, water absorbs the heat, so uh, less changes,
what
right?
condenses? Find out it properly the answer, because it's like water condense when air parcel is moving up, or in the, or it's a and because of the condensation of water and latent heat uh, of condensation, there is some phenomena. You have to explain it. I'm not going to explain it to you. You can go through the books and you will find it out. In case if you will not find it out, then I will let me know. Okay, so then stability class, I already almost I explained what is the stability class: neutral, stable, and unstable. Okay, so a first picture is showing the temperature, the stable, absolutely stable class. What is this? Actually, say this is the air parcel. Green one is the dry air parcel without any water content. Red one is moist air parcel. Okay, moist lapse rate. And the first column is actually environmental lapse rate. Say environment, or the present environment has 4 degrees centigrade lapse rate. Okay, 4 degrees centigrade lapse rate means the temperature, say if the temperature on the earth surface is 15 degrees centigrade, then after a kilometer it will be 11 degrees centigrade, 7, 3, and so on. Now if the air parcel is dry, okay, what will happen? Its temperature, say at the ground is 15 degrees centigrade, but it's a dry air parcel, uh, which means there is no moisture inside it. So its lapse rate, or when it moves up, the temperature will reduce by 10 degrees centigrade per kilometer. So its temperature will become 5 degrees centigrade. Now the temperature outside is greater than the temperature of the air parcel, right? So what will happen? The temperature outside is greater than the temperature inside the air parcel. So that means the air parcel, the density of air inside the air parcel will be higher than the density of surrounding air, right? So this air parcel will be heavier and it will not move up, it will actually sink. Fine? Is that clear? Just tell me, is that clear?
Yes, ma'am.
Similarly,
Yes, ma'am.
with the air parcel moves upward, um, the temperature inside the air parcel will remain lower than the surrounding air, and therefore it will be heavier. The air parcel will be heavier and it will restrict the movement of the air parcel in the upward direction. Even the, hello, if the air parcel is wet, it has some water. Even in that case, what will happen? They say the temperature of the air parcel at the ground is 15 degrees centigrade, whatever the temperature of the ambient atmosphere near the ground. Then its lapse rate is 6.5, right? Say 6 degrees centigrade per kilometer. So its temperature will reduce to 9 degrees centigrade at 1 kilometer, 3 at another 1 kilometer, and so on. And therefore again the temperature of this air parcel will be lower than the surrounding temperature. The air parcel will be heavier, therefore it will sink, it will not go up. Right? Clear? No question, right? Is there any question? Okay. Then the second case, absolute unstable. So in that case, say if the temperature of environment, which is environmental lapse rate, is greater than the lapse rate of the dry air parcel and the lapse rate of wet, even the moist air parcel, which is 11 degrees centigrade per kilometer or 12 or something, means greater than 10 degrees centigrade per kilometer, then what will happen? The same explanation you can have. The dry air parcel, which has the lapse rate of 10 degrees centigrade, will move up and its temperature will become 5 degrees centigrade, while the surrounding temperature is cooler than the air parcel. Therefore the air parcel would be lighter than the surrounding air, and therefore it will go it will further move up. Okay. In case of wet air parcel, its ground temperature is 15 degrees centigrade. Once it moves up, its temperature reduces to 9 degrees centigrade. Again, this temperature is higher than surrounding environmental temperature. Therefore, this air parcel is lighter than the surrounding air. Therefore, it will further move up. So this is unstable condition. Means there is a turbulence. There is a movement of whatever we are emitting on the ground surface, it will move up. Okay. And good dilution and dispersion will happen, and therefore less concentration of pollutant will remain near the earth surface. And this condition we generally see during the summer, while absolute stable condition or inversion condition occurs during the winter. Now, conditional unstable. Now, if the case is in between these two cases which we have discussed, 4 degree and 11 degree centigrade, say if the environmental lapse rate is 8 degrees centigrade per kilometer, then again what will happen? This air parcel will try to move up, its temperature will be lower than the surrounding temperature, and therefore um, it will not go further up, and it will try to sink. Okay, it will try to come down, right? But if the air parcel is moist, so when it is dry, probably it will not move up. But when it is dry, then the temperature of this air parcel at 1 kilometer will be 9 degrees centigrade, while the surrounding temperature is 7 degrees centigrade. So air parcel is warmer than surrounding air, therefore it will go up. So this is conditional unstable, means there is a condition. If the air parcel has moisture, it will move up. If the air parcel is dry, it will not move up. Okay. Then conditional instability. So there is the difference between these two situation. Here what is going on? The dry air parcel moved up and the temperature is about 5 degrees centigrade, while the surrounding temperature is 7 degrees centigrade. But say in this position it gets some moisture, or somehow it gets like some maybe because of the transport of moisture from some other place or whatever, then what will happen? It gets moist and its temperature lapse rate will change. Say now the lapse rate has changed, and its temperature at some point becomes 0 degrees centigrade. Now from 0 to like at 1 kilometer -6, so the temperature will become -3, -9. So as the temperature lapse rate has changed, right? So the temperature of this air parcel will be higher. It's higher or lower? -1, -3. Which is higher? Which is
-1 is higher.
huh?
-1 is higher.
Yeah, yeah. So see, -3. This has like what you say, the lower temperature -3. Therefore, it should sink, right? Because it has some moisture. The moisture will start condensing, and this may lead to the formation of cloud in this particular zone. That may happen. Okay, this is conditional instability. Okay, it's like instability or stable, they are kind of similar word, right? When we say stable or instability, it's a similar kind of you can say has similar expression. So that is the actually stable condition, but because of the moisture in the air parcel, it's getting condensed and forming the cloud. Okay, so this is the condensation happens when this particular kind of situation occurs in the atmosphere. So other than that, there is one very famous phenomena in the atmosphere is inversion, temperature inversion or thermal inversion, right? Temperature inversion happens during the winter time when the earth surface gets colder and colder. With onset of winter, what happens? The temperature, the stagnation or the wind velocity near the surface starts ceasing. It's like decreasing. You can say like wind is more stable around the earth surface, and because of that stability means low turbulence, you can also say it as a low turbulence or no turbulence even, the pollution remains near the ground, and therefore uh, it reduces the energy which is reaching to the ground surface, and the temperature lapse rate is now inverted. So temperature near the ground should be higher, and the temperature decreases with height. That is the normal condition. Now the temperature at the ground is low. Okay, and because of the pollution which is residing in the near atmosphere, it will absorb the solar energy, and the temperature above this layer will start increasing. Okay, so this is opposite to what the normal condition is. This condition where temperature at the ground surface is low and temperature in the upper layer is high is known as inversion phenomena. Okay, so it's an invert temperature lapse rate. Now this is simple example how to calculate the lapse rate. Lapse rate is actually the change in temperature with respect to height. So two elevation is given, two temperature is given, then you can calculate the lapse rate by changing this temperature to Kelvin. So T here is in Kelvin and Z is in meter or kilometer, whatever you want, you can take it. So it's very simple. Now, atmospheric dispersion. I prefer to take this atmospheric dispersion in a separate class because uh, I would like you to practice the examples of this inversion related questions or conditional stability, instability related question first, and then we will come to the atmospheric dispersion because it's related to dispersion plume model, which is a separate, you can say, a separate topic. So I would stop here. Next class we will learn about the atmospheric dispersion, probably not the next class, Tuesday, right? Tomorrow is Wednesday, so tomorrow we will have class. So probably what I am trying to do is to shift the class in Tuesday on Wednesday. That is more suitable for me because on Friday I am having more meetings. So is that okay for you? Means I think you have a slot on Wednesday. So Tuesday, Wednesday we will meet. In any case, like if I am not able to take class on either Tuesday or Wednesday, I will take class on Friday and I will announce that. Okay. In March, probably I will go for a meeting out of station. So probably I will try to cover the classes before I leave, or maybe I will take few classes even because it's online classes. So I will announce this online classes I can take even I'm outside, but I don't know how much time I will get. So I will try to cover those classes on extra slot. This is what I'm trying to say. Okay. So let's stop here. Do you have any question regarding what we have learned today?
Uh, Hello, ma'am. Can you hear me?
Yes, yes.
Yeah, ma'am. I can only see the slide of the first lecture on Teams right now. Can you please upload the others as well?
No,
I could only see the
other
first one.
1 minute, 1 minute. Let me just see. I have uploaded all. Let me just see. Okay. Because see, where are you seeing? You went to files
Yes, ma'am.
and then class material. Huh? I uploaded the files in this. Okay, let me see how come it is outside. How many slides we have outside? Files. I uploaded on class material only. Lecture 1. Okay, I don't know. Okay, I will upload it again, but I remember that I uploaded the files. Maybe I. Okay, I will upload it. I will upload
All
all.
right, ma'am. Thank you.
Okay. Okay. Is there any other question? So in no, the today whatever we have learned, is that clear? Aditya Garg, Aditya Jain, Aditya Katur, Aditya Raj,
Yes, ma'am, it
Abhishek.
is clear.
Rashmi, I know you are here, but I just want to know if other who have logged in are here or they have just logged in and went away. So Akhila,
So, ma'am,
yeah.
what's the
Yes,
final
ma'am.
attendance policy? Like you told, you will be telling the final attendance policy.
Okay, yeah. So regarding attendance policy, we have uh, the student should attend at least 30 minutes of the class. Okay, 30 minutes and should log in before 8:15. Okay, if even if you have an internet problem and you logged out and again logged in, whatever, like 3 or 4 times, we will consider that, but minimum 30 minutes of the class should be attended because we have like 50-minute class. So 30 minutes is the minimum requirement of getting the attendance, right? And one should log in before 8:15 in any case. Is that clear?
Okay, ma'am.
Okay.
Yes,
So
ma'am.
Yes, ma'am.
okay. So
Hmm.
the topic is also clear and the attendance policy is clear. We are going to have. Okay, I also decided the date of assignment. Let me just tell you the date of the assignment. 1 minute. So date of the assignment in 1 minute. So 15th is your exam, right? 15th March. So
Yes,
I
ma'am.
think
Yes, ma'am.
15th is Monday. So you will have your assignment a week before your exam. Okay, fine.
Okay, ma'am. How much
Okay,
time will
fine.
be
Yes.
given for assignment, like 1 week
So
duration or?
it depends if probably we try to have the numerical question. So if it's a numerical question, accordingly the time will be given for online submission of the assignment. If it's a theoretical question, then accordingly more time will be given compared to means it
Yes, ma'am.
depends upon the question. Okay.
Okay, ma'am. Thank you.
So probably it would be online only. And whatever exam you are giving or assignment or quizzes, if you do any extra work on your sheet, like one paper, you have to scan the paper and upload. That instruction will be given to you before the exam on instruction sheet. Okay, right? We
Okay,
will
ma'am.
go through your solution and try and see like whether you have solved the question correctly or not. Though your answer is correct or incorrect, whatever, then only we will give you the mark. Okay. Probably the detail policy regarding this sheet upload and how this will be checked and all will be announced before the exam. Okay. Fine.
And ma'am, can you consider the attendance after airdrop period, since I have added the course on last day of airdrop period?
Yeah, so I told you that I will consider the attendance after add drop period only in case a student say he has 89% attendance and he is just missing by 1%, but he claims that he has already done some classes before add drop, then I will look into that. So it's like if a significant attendance you have and you are missing with just 0.5% or 1%, whatever, then I will give you can say bonus attendance considering your attendance before and drop.
Okay, ma'am.
Okay, fine. Okay, so we are stopping here. We will join tomorrow to discuss the dispersion modeling. Fine. Thank you. Bye.
Thank you, ma'am.
Bye, ma'am.
Bye.
Thank you.
Thank you, ma'am.
Thank you, ma'am.